Here is the beginning of a double canon composed by Johann Joseph Fuchs from his Missa di San Carlo. As the name suggests, a double canon is one made of two simultaneous canons. In this case, we can see a canon at the upper octave at a distance of one measure. I will call this blue combination Proposta 1 and Risposta 1 to distinguish it from the other canon. At the same time, Proposta 2 and Risposta 2 form a canon with completely different melodic material. But they happen to have the same parameters, an interval of entrance at the upper octave, and a distance of entrance of one measure. However, this is only one way of viewing the contrapuntal texture. It would be just as true to view the four voices as two non-imitative combinations, a purple combination of both proposta voices, and a red combination of the two risposta voices. This alternate way of slicing things is useful because it allows us to construe the purple combination as an original and the red combination as its derivative under some form of movable counterpoint. We could not do this under the previous perspective because the orange P2 and R2 combination is not a derivative of P1 and R1. They're separate canons and thematically unrelated. But both perspectives have their usefulness, and throughout this video, I will try to be using the colors consistently. Blue and orange mean that I'm viewing the double canon as two separate canonic combinations, while purple and red will mean that I am viewing the double canon as original and derivative non-imitative combinations. In this example, it is easy enough to determine the vertical shift index that relates the original purple combination to the derivative red combination. We reach into our analytical toolbox and pull out Old Faithful, JV equals n minus m. We can take any harmonic interval from the purple combination, let's say this fifth on the downbeat of measure 3, which is 4 steps of the scale, therefore m equals 4, and compare it to its corresponding derivative interval, which in this case would be the fifth in measure 4. 4 minus 4 is 0, and so this original combination can be composed in simple counterpoint. Notice that both of Fuchs's canons are at the upper octave. Since 7 minus 7 is also 0, it looks as if we could use the intervals of entrance to calculate JV. However, this is a less reliable way to determine the vertical shift index. It happens to give us the correct answer in this case, and, in fact, we can even conclude that any double canon, whose two canons have the same interval and distance of entrance, will have a vertical shift index of 0. In my experience, this seems to be the most common pattern for a double canon, and it is much easier to compose than one might at first assume. But we will use the non-imitative combinations to determine JV going forward. Only a few measures earlier in the same work by Fuchs, we find another example of a double canon. The P1 and R1 canon is formed at the upper ninth, at a distance of half a measure, and the P2 and R2 canon is formed at the lower ninth, also at a distance of half a measure. Unlike the previous example, these two canons have different intervals of entrance, and so the vertical shift index will not be trivial. Pause the video if you want to try to calculate it yourself, otherwise I will show you the answer. Here are the two non-imitative combinations. We can pick any harmonic interval from the purple original combination of the two proposta themes, such as this 12th on the downbeat of measure 3, which tells us that m equals 11, and then compare it to the corresponding interval half a measure later, which is an inverted sixth, so n equals -5. -5 minus 11 gives us a vertical shift index of -16, which is essentially just invertible counterpoint at the 10th. It's a 10th plus 1 octave. Normally, invertible counterpoint at the 10th means that we need to avoid parallel and direct motion, even with imperfect consonances, since they will invert into perfect consonances. But it is interesting to note how Fuchs apparently made no effort to avoid hidden octaves and fifths in his canon, even within the original combination. This is a great example of do as I say, not as I do, since the Missa di San Carlo was composed in the early 1720s, right around the same time that Fuchs admonished us not to do this in Gradus ad Parnassum. In both of these examples by Fuchs, the two canonic combinations had the same distance of entrance. This is what allows us to analyze the purple and red combinations as original and derivative related by vertical shifting counterpoint. But what if the two canons of a double canon have dissimilar distances of entrance? I couldn't find an example of that in the literature, so I composed one myself. The asterisks indicate where the canonic imitation breaks off. The blue P1 and R1 combination is a canon at the lower octave at a distance of 2 measures, while P2 and R2 is a canon at the upper octave at a distance of only 1 measure. If we shift perspectives to look at the non-imitative combinations, we can quickly see that P1 and P2 cannot be transformed into R1 and R2 by vertical shifting counterpoint. The derivative voices have also been shifted horizontally relative to one another, so that they begin together on the downbeat of measure 3. This means that we will need to use double shifting counterpoint to find the placement of an imaginary voice that will help us in composing this type of double canon. Relative to the original combination, R1 has been shifted 7 steps of the scale downward, that is to say, in the direction of P2, so it has a vertical shift of -7. And it has been horizontally shifted 1 measure forward so that it begins at the same downbeat as the other voice. R2 also has a vertical shift of 7 steps in the direction of the other voice. We can find the vertical and horizontal shift indices by summing these component shifts to get JV equals -14, invertible counterpoint at 2 octaves, and JH equals 1. These are the constraints on the composition of the purple P1 and P2 combination. Composing that combination under those constraints becomes much easier when we apply an imaginary voice. For example, I could take the notes of Proposta 1 and transpose them by the vertical and horizontal shift indices. I could then focus on composing the P2 voice so as to fit in correct counterpoint with P1 and the imaginary voice independently. Taneev would call that 3-voice setup a basic version. The counterpoint between P2 and the imaginary voice is a transposed copy of the red P1 and R2 combination. Notice that we had to transpose by JV, the vertical shift index, rather than any of the component vertical shifts, in order to find the correct placement of the imaginary voice. Now let's consider an example of an infinite double canon, this one composed by Mozart. P1 and R1 is a canon at the upper fourth with a distance of entrance of 1 measure, while P2 and R2 is a canon at the lower fifth with a distance of entrance of 1 measure. Since the two canons have the same distance of entrance, we can use vertical shifting counterpoint to relate the two non-imitative combinations. If we grab this downbeat octave from the original combination, so that m equals 7, and compare it to the corresponding interval from the derivative where n equals 14, we can see that JV therefore equals positive 7. This is basically just simple counterpoint plus 1 octave, so simple intervals will become their compound equivalents. Now we can apply the analysis for how repeats are accomplished in an infinite canon, which is reviewed from the previous video in the series. For this, we return to the canonic perspective. Since there are two canons, we just need to check that each canon forms a successful repeat. Mozart's canon has 7 measures between the repeat signs, so both canons will have a shadow distance of entrance of 6 measures. This tells us that the problem of the repeat for both canons will involve double shifting counterpoint and an imaginary voice. For the P1 and R1 canonic combination, we can find the doubly constrained section by applying our conveyor belt analysis. In this case, the material in the red box must work below the precomposed material in the orange box in measure 7, and above the precomposed material in the purple box in measure 9. We can find the placement of the imaginary voice by shifting the notes of the purple box back 1 measure in order to undo the distance of entrance of the canon, and down a perfect fourth, which undoes the interval of entrance. For the P2 and R2 canon, the doubly constrained section occurs in this red box, which needs to work above orange and below purple. And again, the imaginary voice is placed opposite to the interval and distance of entrance of the canon. So it turns out that infinite double canons are straightforward to analyze. We apply the same analysis of the non-imitative combinations from earlier in this video, and then analyze the canonic combinations for their repeats, as we saw how to do in the previous video. Lastly, and mostly just for fun, let's have a look at one very complicated example. Within the choir, we can find a double canon. The tenors and basses form a P1 and R1 combination at the lower seventh and at a distance of half a measure, while the sopranos and altos form a P2 and R2 combination at the lower fifth, also at a distance of half a measure. But as if that weren't enough, Mozart also places the basso continuo and the first violins in canonic imitation, so that overall we actually have a rare example of a triple canon. The P3 and R3 canon is formed at the upper 13th, at a distance of half a measure. Mozart is being merciful by placing all 3 canons at the same distance of entrance, so that we can relate all 3 proposta voices as an original 3-voice texture, which itself contains 3 combinations, to the 3 risposta voices as its derivative 3-voice texture under some form of 3-voice vertical shifting counterpoint. Here we can see the original and derivative combinations laid out on separate systems. I'm also going to relabel the voices using the Roman numerals that we looked at near the end of the video on vertical shifting counterpoint. Bet you thought we weren't going to get quizzed on that, but here we are. The top voice of the original is labeled uppercase 1, the middle voice 2, and the lower voice 3. We can then convert the interval of entrance in the rispostas into vertical shifts. The voices have all inverted relative to one another according to Taneev's diagram 4. Voice 1 is transposed down 4 steps of the scale. Voice 2 is shifted down 6 steps of the scale. That would be 6 steps away from voice 1 and 6 steps towards voice 3. And voice 3 is shifted up 12 steps. And again, because all 3 canons have the same distance of entrance, these three derivative voices have no horizontal shift relative to one another, although the downbeat has shifted for all of them. Now we can find the vertical shift indices for each of the three combinations. JV prime, which is the relationship of voices 1 and 2, is -4 plus +6, which is +2. This is very similar to invertible counterpoint at the 10th. And here, for example, we can see an original 10th becoming a derivative 12th. So we're adding a third to every original interval. JV double prime is the relationship governing voices 2 and 3. -6 plus -12 is -18. This vertical shift index is very similar to invertible counterpoint at the 12th. We can see that these voices mostly move in parallel thirds in the original, which become parallel tenths, or really 17ths, in the derivative. And finally, JV sigma is the relationship governing the outer voices 1 and 3, and it is also the sum of the other two vertical shift indices. -12 plus -4 is -16. This is, again, essentially invertible counterpoint at the 10th, and we can see an example here where a fifth in the original becomes an inverted 15th in the derivative. Was Mozart thinking of all of this when he composed this brief canonic passage? I don't know. I suspect he was thinking more from a top-down perspective, starting with a circle of fifths progression, and then finding a clever way of transposing the chord tones from one three-note voicing of the triad onto chord tones of the next harmony in the pattern. But even that is much easier said than done, of course. Taneev's bottom-up method allows us to analyze these kinds of complicated passages very precisely. And he wrote that he hoped that understanding the underlying mechanisms might allow later generations of composers to explore possibilities that had not been attempted in previous literature. Maybe we don't have to be Mozart in order to compose something similar to this. I will leave you with a few beautiful examples of double canons composed by Brahms that you can use for practice analysis. In the Geistliches Lied, especially the a cappella middle section is worth studying, as well as the gorgeous coda. From the Opus 113 canons for women's choir, numbers 8 and 9 are both infinite canons.